Welcome to Physics 2, Bar Magnet Lab number 4. Introduction. The purpose of this lab is to use Biot-Savart's law to find the distance dependence of a magnetic field due to a bar magnet and to understand how observation distance is related to magnetic field. The models and fundamental principles that we'll be covering are magnetic field of the dipole, the fact that magnitude is inversely proportional to the distance cubed between observation location and the dipole, and then Biot-Savart's law. The preview of the main results is that the magnetic dipole moment is 2.9 am squared. The predicted B at 45 degrees from the code is on the screen, and then the actual B from the lab experiment is the third bullet point. Lab. Okay, the main physics ideas. So magnitude is inversely proportional to the observation of the dipole. In the image, you can see how the magnetic field is shaped around the magnet. So it goes from north to south and then pointing, like looping, and then straight above. And then the magnetic field dipole is Biot-Savart's law, so then that's the equation. And then we also need to know how to find the magnetic field on an axis and off the axis. And then those are the two formulas. System and surrounding. The system is the bar magnet and the magnetometer, which is my phone. And then the surrounding is everything else. So the tape, the ruler, the table, the rest. Okay, so the procedure was to orient the magnet and yardsticks to the true north direction to cancel out the impacts of the Earth's magnitude, and then use the magnetometer mark app on phone and mark with tape to find where the magnetometer is on the phone, and then conduct 3 tests with the on axis, and then conduct 3 tests on the off axis to reduce error, and then put that data into an Excel sheet to analyze. Assumptions and sources of errors. The assumptions that we made is that the only magnetic force that the phone was reading was from the magnet, and that our distance measuring was fully accurate the entire time. Sources of error were the phone not being flat due to my phone case, human error in data collection, and then the phone reading magnetic signals from other sources beyond just the magnet. So like from wires, from the phone, from other things. Okay, here's my on-axis data. So here's a copy of the spreadsheet, so showing the average distance, the average magnitude, and then the chart showing the inverse relationship between distance and magnetism. And then my off-axis data, the 2 important parts are the distance, which was 0.32 meters, and then the net magnitude, which is 2.9 times 10 to the minus 5. Here's the details of my code. The important parts are the parts that I plugged my own values into from my experimental data. So here is when I edited it to account for my magnetic field that I calculated before. And then here shows all the axes and the arrows that are created. And then again, from the measurements I had in my actual lab, had the same data points, and then here was the result. So then I got the here is what my GlowScript model came out with. The orange arrow is the on-axis measurement, the blue arrow is the perpendicular to axis measurement, and then the purple arrow is the off-axis. And then from this, it calculated the predicted B, which is right here in the middle for me. Analysis. Okay, similarities and differences between my lab and code. My code had no Z component, and my code predicted a magnitude slightly higher than what was actually done in lab. Why this is different would be the strength of the magnet accounted for in the code versus my actual magnet, and then it was very similar in magnitude and like range of values. Sources of error. Phone not being flat, human error, and then phone reading other magnetic signals. And then what if the X value of the magnetic field would be off because of the other value? And then if you had 2 magnets together, the magnetic field would increase and be bigger. And then discussion, the statements that describe what I observed is that the magnetometer is far away from the magnet. It measures near zero magnetic field in the x direction, and as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. That's it. Thank you.